Good day, everyone. My name is Noel Gerwick. I'm a technical advisor in the Office of Global Climate Change at USAID. I want to welcome everyone to today's installment in our webinar series on land use and climate research by the CGIAR. USAID has been working with the CGIAR on research that supports action to reduce greenhouse gas emissions and store carbon in the land sector for a number of years. Many different CGIAR research centers and programs have been involved, and we all decided it would be a good idea to bring the results from these research efforts together in an accessible format. We hold these webinars roughly once a month. The schedule, as well as the recordings of all the past webinars, is listed on our Climate Links website. We started in March this year with a presentation by CIAT researchers on forest restoration and the 20 by 20 initiative. Others so far are focused on wetland science and policy by C4 scientists, feasibility and investment for low emissions rice in Vietnam by ILRI scientists, and the measurement and reporting of agroforestry based carbon by ICREF. So today's is the fifth installment. The title is Identifying Opportunities for Reducing Emissions from Livestock and Creating an Investment Plan. We have three presenters, Lini Wollenberg, who leads the Low Emissions Development Flagship at CCAFS, and Polly Ericksen and Todd Crane of ILRI. So I'm going to now turn it over to Lini and welcome everybody.
Hi, everybody. As Noel said, we do have three presentations, and I'm just going to jump right into the first one. My name is Lini Wollenberg, and I lead the low emissions program of the CGIAR research program called Climate Change, Agriculture, and Food Security, or CCAFS. And I'm going to give a quick overview of the livestock sector in East Africa. So what are the numbers? We have a huge amount of cattle in East Africa and livestock generally. 132 million, with Ethiopia comprising about 46% of that, so the largest numbers in Ethiopia. And those overall East African numbers comprise about 9% of the global cattle population. So a significant portion of the livestock emissions globally do come from East Africa. At the same time, 9% of the global cattle population, yes. And at the same time, cattle are, of course, a major source of livelihood, contributing anywhere from 11 to 40%, 45% of national GDP, and 70% of cash income, and particularly important, of course, for smallholders. We've seen tremendous growth in the livestock sector over the last 2 decades, and it's not going to stop. We know that the population is going to at least double by 2050 in East Africa, and we're also going to see the calories per person doubling likely, with an increasing demand expected for meat and dairy. The problem, of course, is that we have a variety of different systems, which isn't necessarily inherently a problem, but within those systems, we have a huge gap in milk yields and meat yields. So meeting that future demand is going to be problematic, assuming that demand materializes. So milk yields in terms of kilograms per cow per day vary anywhere from 1 to 18 kilograms, and the types of systems suggest that different kinds of approaches will be needed. So that's the picture about livestock in terms of numbers and livelihood importance. As you can imagine, emissions are also growing. So Eastern Africa contributes also 9% of global livestock emissions, and those emissions in the region are 2 to 6 times higher than other regions of sub-Saharan Africa. And of course, they are also growing. So over the last 2 decades, we've seen a 49% increase in livestock emissions in the region. Most of the emissions are from cattle rather than other livestock. So of course, with the Paris Agreement and efforts to create mitigation targets, then you can imagine that livestock is an important sector for countries to consider in their NDCs, or their nationally determined contributions. And using numbers from the 2017 NDCs, and some of these numbers have been updated since, we can see in the dark blue and the red where mitigation targets that involve livestock occur. And so you can see globally, livestock important countries like Brazil and China and Europe, including livestock, some notable countries like Canada and the US not. But also then in East Africa, you can see that we have a mix. We have some countries in dark blue that have chosen to include mitigation targets, and some in the light blue which have chosen only to include adaptation targets. Fortunately, there are an array of options for achieving mitigation, and ILRI has done a nice study looking at 10 options, and I'm highlighting only 5 here and exploring the feasibility of those. And Polly Ericksen is going to speak a little bit more about the fodder option in particular and give you some information about the investment needed associated with that. So what are some of the feasible low emissions development options? First and foremost is improved forage for animal feed. And we think that we can achieve about an 8 to 24% reduction in terms of emission intensity on certain kinds of farms. And as much as 27, that's in Kenya, and as much as 27% in mixed systems in Ethiopia. Manure is also important, of course, and you can achieve absolute emission reductions with manure. So biodigesters, we think, can reduce manure emissions by 60 to 80% in intensive dairy farms of at least 4 cows, and that improved manure storage generally can reduce emissions up to 90%. And then some options that people don't usually consider are related to health and reducing chronic disease, for example, and that can reduce the emission intensity of livestock due to the increase in productivity, although the rate of the mitigation achieved depends on the disease that's targeted. And finally, changing the herd composition by reducing slaughter age while improving feed quality can reduce emission intensity by up to 40%, we think, in sheep and goat systems and 34% in extensive pastoral systems. The choice of the mitigation option is really critical and can sometimes involve trade-offs. And so, for example, in Kenya, there's a nice study that is looking at, can we achieve the 30% reduction in GHG emissions that Kenya would like to achieve by 2030? And this is another study out of ILRI. We know that improving forage quality of, for example, Napier grass and dairy concentrate supplements can reduce emission intensities by about 26% to 31%. And mind you, that's emission intensity. And at the same time, it can partially achieve the national milk productivity target for Kenya by 2030 by 38% to 41%. So a nice balance of both achieving some mitigation and achieving milk targets. And it's a very highly feasible option given the availability of arable land specifically suitable to Napier grass. But this is in contrast to using, for example, maize silage as the improved fodder, which would increase emissions up to 10% based on scenarios about the land conversion that would be required if we were to grow more maize. So just a reminder that with each of these options, the trade-offs need to also be considered. The other consideration in achieving mitigation, of course, is that farmers aren't already doing this, and so what's necessary to help them shift to new practices. And the typical barriers, and this is not just in East Africa, but probably globally, is the initial cost of investment, poor information that is available to farmers and extension services, and a lack of public and private sector incentives or investment generally. We also see that adaptation to climate change is often the priority. Women and other marginalized groups, of course, will face additional constraints, whether that's a lack of ownership rights or decision-making power, a role confined to informal markets, or a whole host of other factors. A very nice publication also out of ILRI is a best practice guide to social and gender inclusive low emissions development in livestock. It provides, for example, a nice list of indicators for assessing whether you're reaching the populations that you're trying to reach. So, who's registered with the producer organization, who's delivering the milk, the number of marginalized people in leadership positions, and so on. So that's a resource that I would recommend to you. So to overcome some of these barriers, we're fortunate that we're in an era where countries are starting to allocate climate finance, and countries are making what are called nationally appropriate mitigation actions, or NAMAs, to try to match plan for mitigation, to implement mitigation with that finance. And for example, the Green Climate Fund just had their board meet this week, and they have an overall portfolio now of about $5 billion with over 100 projects in almost 100 countries, and are just one example of the type of climate finance that is available. And in East Africa right now, there's quite a bit of interest in several livestock NAMAs, but the Kenya dairy NAMA has been one of the first. It's involved a number of our CGIAR partners, Unique Forestry and Land Use among them. And it's targeting over 400,000 farmers, trying to achieve about 8.8 million tons of CO2 equivalence mitigation through a variety of measures, including increased dairy productivity, improving the energy efficiency in milk processing, and through biogas. So we have the opportunity to use that finance to overcome the barriers, but the question is how much money is needed. And so that's where I'm going to now turn over to Polly Ericksen to continue the presentations. Thank you.
Good morning, good afternoon, depending on where you are. I'm Polly Ericksen, and I work at the International Livestock Research Institute based in Nairobi. And so I'm going to talk a bit about a case study that we did on the improved fodder production as an investment opportunity, both from the perspective of farmers as well as possible development partners. And I should note that this work was done in conjunction with a small company here in Kenya, Strategic Business Advisors. That's John Kashengaki. So I just want to remind people about kind of the theory behind reducing emissions intensities through interventions that have the additional benefit of increasing productivity. So this is a graph showing sort of the exponential decline in opportunities to reduce emissions intensities in higher producing animals. So once you get to milk production over about 1,000 kilograms per lactation, the opportunities to reduce emissions become quite small. But in many of the systems where ILRI works across Africa, Asia, and in some parts of Latin America, there are very marked potential for increasing productivity. So you would, as you increase the milk yield, you simultaneously decrease the greenhouse gas emissions intensities. So that's the premise behind a lot of this work. So why are we focusing on dairy? And this is also the focus of the dairy of the NAMA that Lini just mentioned. It's because Kenya's dairy sector is one of the largest in sub-Saharan Africa. It contributes 8% of the GDP. And semi-intensive or intensive dairy amount to about 65% of the total emissions from livestock in Kenya. It's the fastest growing agricultural subsector, and there's increased investment in processing and marketing. However, adequate feed availability and quality is a prerequisite for any of the other improvements, and that's really why we chose to focus on a business case for fodder production. So what we know about current feeding practices and gaps is that in these intensive and semi-intensive dairy systems, farmers use natural opportunistic grazing, but they complement it with planted fodder, crop residues, limited use of concentrates. In some intensive systems, you largely have stall feeding, so it's cut and carry operations. The challenge really is seasonal fluctuations and shortages in the dry season, because the vast majority of the fodder production is rain-fed. An optimal feeding regime would be about 75% energy and 24% protein. So what, this is from the earlier study that Lini alluded to, where we looked at these 10 different low emissions development options. And the barriers that we identified through focus group discussions and key informant interviews were first, low availability of land to grow forages. People's need to have diversified cropping strategies. So it's challenging for many of the dairy farmers to specialize in something just like fodder production. And then the low accessibility of improved planting materials. So as part of this business case, we also asked people about what would be potential incentives that could encourage greater uptake of improved forages. And we identified field trials to improve farmer awareness, investments to stimulate fodder seed production and start to put in place a certified seed system. And then this last one is really assisting farmers to kind of do a better cost-benefit analysis of their overall farming strategy. Should they specialize more or might they diversify more? And so this last premise is formed the foundation for the business case analysis that John and colleagues took forward. Just a couple of other higher scale interventions or constraints to bear in mind is that many of these investment opportunities have been focusing on farmers with a commercial orientation, because that's often, and so that degree of market orientation is often seen as a major precondition for upgrading. But as Todd will talk more about, the majority of the milk produced in Kenya is actually sold on the informal market. And if you want to achieve gender equity, then you need to consider these informal markets. And what Todd and colleagues have found since we finalized this study, so over the last year, is that actually there are some more promising income earning opportunities through the informal market, particularly for women. The second higher level constraint is that even with market orientation, low milk prices tend to inhibit investment in upgrading. And so that's really a factor that's out of the control of the producers. And then there's an issue around low trust in and a perceived low level of accountability of input services. So people don't necessarily trust the seeds that they're buying or the advice they're getting from agri-vets or other forms of extension agents. So to do this business case, I'm not going to, there's a lot of numbers that are going to appear in the next slides. The business case itself is available online as a CCAFS report. It has the same title as the slide production. But what we did is we interviewed farmers from 5 counties in the Central and Rift Valley region. So these are the parts of Kenya where intensive and semi-intensive dairy is the most concentrated. And then we tried to choose farmers that varied in terms of their average land size, their current levels of milk production, and what their available feed basket is. And then for these sort of typical farmers per county, we costed out 3 cases. One is the cost benefits of their current practice. The second would be if they introduced growing fodder into their farm. And then the third would be the trade-offs between, the third option is if they grew a different crop and used that income to purchase fodder. So 3 different scenarios. So this is the evidence for the first case for Murang'a County. And so you'll see that we have a best case scenario where we assumed a good price for milk and a lower price for hay, and a worst case where the milk price was lower and hay was more expensive. And then we calculated the revenues that that farm would achieve from milk sales, calf sales, and from manure. And then we put in place their costs for dairy meal, hay, labor, water, pesticides. And we did gross margins. That's the row that you see at the bottom. And so you'll see under current land use, for this particular farmer, his gross margin in the best case scenario is 1,900 shillings. And in the worst case scenario, he's making a loss of 10,000 shillings. Now, if we move to the one of the alternative business models that we're interested in assessing the feasibility of. So this would be if they grew fodder on 1 acre. And so you'll see that under the best case scenario, this particular farmer actually has the opportunity to increase his gross margin and these are monthly rates, to 33,000 shillings. And even in the worst case, he could increase his gross margins to 16,000 shillings a month. So quite promising. And then the third case was if instead of growing fodder himself, he grew another crop and purchased fodder. And again, here you'll see that under the best case scenario, he could increase his gross margins by 16,000 shillings, so not as much as if he grew the fodder herself. And then even in the worst case scenario, she could increase her gross margins and have a profit of about 7,000 shillings a month. So this slide presents the gross margins for the other counties as well. And so remember, again, case A is current practice, case B is growing fodder, case C is purchasing fodder. And so the take-home message here really is that in all of the cases, the options of growing fodder or purchasing fodder show significant increases in gross margins across these 4 different counties. And then this summarizes the combined increases in productivity that you would get along, and it quantifies as a percentage the change in monthly profit margins. So again, across the 4 counties, now comparing the worst case and the best case, you'll see that you have a potential to increase daily milk yields on average by 150%, and you would have on average an increased improvement in monthly profit margins. Sorry, there's a mistake on that last slide. Pardon, that should have another 3 next to it, sorry. Okay, so what's the take-home message? Fodder production can generate greater revenue and reduce emissions. So as I've just shown you, both milk yields and profit margins potentially could improve if farmers were to adopt what we proposed as best practice. And again, just repeating the data that Lini's already showed you about the potential for fodder-based interventions to reduce greenhouse gas emissions intensities. So one scenario from FAO and the New Zealand AGGRC says that you could reduce emissions intensities by between 8 to 24%. Of course, this depends on assumptions that you make about adoption rates. And then the Brandt et al. Analysis that she shows that you could get higher reductions if you combine forages with concentrates. So now I want to talk about what at the project level, what an investment in a fodder project would require and how long it would take for it to break even. So the blue line are the total project investment costs over 5 years, and the red line is the total project benefit. And so you see that quite quickly after year 2, the benefits start to outweigh the investment costs, and by the end of 5 years, the project benefit is quite significant. But I want to, again, talk a bit about, so this kind of an investment project would be one that would be focused on stimulating farmers to adopt the fodder production practices that I showed you in the business case modeling. And so what that will require is support from these other value chain actors. So in Kenya, in the intensive and semi-intensive dairy production sector, cooperatives are an extremely important source of information, source of access to finance and credit, and they are used. They are the mechanism through which smallholder farmers formally market their milk. And so, for something like the Kenya Dairy NAMA, these cooperatives are a really important vehicle between the large processors and the smallholder farmers producing a lot of the milk. So, for a project such as this one, you would need to work through the cooperatives because they're networks that share information. They could help to stimulate fodder markets because they can make bulk purchases on behalf of their members. They could also stimulate other input markets. A question that remains is the extent to which cooperatives have any ability to improve or stabilize milk prices, because as we mentioned at the beginning of the presentation, those low milk prices still represent a barrier to farmer ability to or willingness to invest in upgrading. So then the same questions pertain to what the role of these large processors would be. So there's 5 to 6 large dairy processors in Kenya through which most of the milk that someone like me drinks or purchases are marketed. And so again, we come back to the question of their ability to stimulate higher milk prices, but they're also a very important source of information about best practice. So as we elaborate in the study, a project proposal for reaching 30,000 farmers across 3 counties with an outcome of a 50% increase in milk production and a 100% increase in fodder production. We estimate that we could achieve a 10% reduction in greenhouse gas emissions intensities per animal. And the cost of that would be about $1.1 million US per county over the 5 years. So the conclusions: cost-benefit analysis suggests that improved fodder production could be profitable in intensive systems. The opportunity cost of land is quite critical, also the risk of fluctuating milk prices. But this is in a context where information and market support are lacking, so the investment project would have to include support for both of those areas. Potential emissions reductions, intensity reductions of at least 10%, and the project investment would see a positive return within 3 years. These are some references with the data that we refer to, and now I'm going to hand it over to Todd. Thank you very much.
And I'm just going to break in. This is Juliana from CCAFS. I wanted to let everyone know, thank you, Polly and Lini, for your presentations. We're looking forward to Todd's. I wanted to let everyone know that we will share presentations after the webinar, and also to tell you that you're welcome to send in questions using the question box on the GoToWebinar control panel. We have about 20 minutes at the end for questions. Thank you, and thank you, Todd.
Hi, thanks everyone. Yeah, I'm picking up where Polly has left off, characterizing some of the impacts of system change, in particular interventions. Wanting to look at what are the pathways and what are the implications for how those practices are promoted. And this is representing work, as you see, by a large number of people from ILRI, from Wageningen University, from the African Center for Technology Studies. Advanced, there we go. So this is summarizing work from 2 interrelated projects. One is a greening livestock project funded by IFAD, and a related project called Inclusive Low Emission Development funded by CCAFS and Dutch Research. The objectives of the greening livestock focus very much on doing basic research on greenhouse gas emission baselines from our environmental science lab, but I'm going to be talking today about the social implications for the implementation of low emission development and looking at the enabling environment for their promotion, what institutionally needs to be done for them to go. This is done in the context of trying to improve support for policymakers as they transition from thinking about to actually targeting, planning, implementing low emission interventions, which is the focus of the Inclusive Low Emission Development Project, is really getting close attention on facilitating and convening work by stakeholders throughout the sector, both in Kenya and in Tanzania, to think about all these implications and how do you move from impact as an abstract thing into a kind of a nuts and bolts approach. Now, just to give some background, we've been really focusing on social differentiations because we thus far have been talking about the counties as kind of as a homogeneous space, but we've started with an assumption or a hypothesis that there is substantial variability existent in the producer populations, and understanding what are the various barriers and opportunities for them to enter into lower emission practices. So in Kenya, we worked in 3 different counties, Nandi and Bomet, in the Rift Valley, and then Murang'a, which is a more intensive agricultural or dairy area north of Nairobi. What we found is that across these different counties, that there's a quite high variability in the way they implement practices and which practices they choose to implement. This slide is illustrating 4 key intensification practices, 4 key low emission development practices. As I said, Murang'a, the green, is the most intensive, which is, I think, evident in this slide. But we see different degrees of investment in different counties in the various practices. So the manure management is much closer in Nandi County, but their investment in fodder production, as we see on the left, is substantially lower than in Bomet. So this is meant to really illustrate and drive home that the sector is not one thing. There's variability in the sector in terms of how different geographic areas and their various endowments and histories have invested thus far in low emission practices, which provides some indication about how they move forward. So this is not just in terms of on-farm practices, but we see a lot of variability in how different producers engage in the value chains. As Polly and I think Lini as well alluded to, most of the milk in Kenya, despite its a very commercial orientation, most of the milk is still not sold in the quote-unquote formal market. This is sold over the fence. It's sold to middlemen who go and sell it in town. Even in the most intensive county, we see nearly a quarter of the milk is not sold, and still another over 50% of the milk goes to direct sales or to informal middlemen who probably go and sell it in town directly. They might sell to processors. So even again, in the most intensive area, it's a fairly small portion of the milk goes into the informal economy. And this particular slide is illustrating the main market channel for producers. So most of them maintain multiple pathways, marketing different milk down different pathways at different times a year, according to their own strategic needs. We see in the middle just an indication of milk productivity, emphasizing the morning milk and evening milk. There are 2 milkings a day, and I'll get back to that here in a moment. And the way people approach services in terms of artificial insemination. There's relatively low investment in artificial insemination, and as Polly alluded to, there's varying degrees of trust and accountability in that system. So again, this is reflective of willingness to invest in that as a way of improving productivity. However, it's not just geography and counties that make the difference in terms of strategies. Even across different households, we did a cluster analysis to understand what different kinds of households are out there in terms of how they implement practices, how do they engage markets, what's their main drivers for engaging with dairy production. And in Kenya, we came up with 7 different categories that reflect varying degrees, but also varying dimensions of intensification. On the left is the least intensive, who don't sell milk. Moving over to the right, who are the most invested, the most intensified. I think it's telling that the productivity, according to this large household survey, isn't that variable across these, even just the commercial categories. Now, what this should illustrate is that we have geographic variability in terms of access to markets and historical investment in the sector, but we also have high variability across households in terms of their motivations, their opportunities and their willingness and interest to invest in low emission development practices. And while in some places there's correlation between the prevalence of certain household types in certain counties, we still see a pretty broad spread of these different household types across the counties. Now we have the same data, same kinds of data for Tanzania, taken from 4 different districts. I'm not going to go through these in such detail, but it's the same kind of data, but again, revealing different patterns of variability across the different regions and across the different household types. It's not nearly as intensified or commercialized in Tanzania as compared to Kenya, so much more, even more reliant on the informal economy. And again, having high variability in terms of what households' motivations are for investing in technological upgrading for intensification and thus lowering emissions intensities. Now, it's not just county and it's not just household, but of course, milking or dairy is a highly gendered activity across Kenya and Tanzania. Historically, morning milk is men's milk, or the more commercial oriented milk, and the evening milk belongs to women to do with what they will. Typically that's been informal sales to get cash in hand, but we see that with increased commercialization, they move to different payment structures, because wherein households receive bulk payments, maybe once a month, maybe twice a month, goes to the household head that amasses the earnings across the month. Of course, this money now goes into the household head's control, and thus women are very unmotivated to engage in the formal economy because they basically get disenfranchised from what otherwise is their income stream. We also see in varying ways that market networks and market activities are construed as a masculine space, as a masculine sets of networks. Again, pointing out that the shift toward formal commercialization is a gendered shift in control of dairy profits and dairying activities. However, we've seen some interesting evidence of women's opportunities in the informal economy, acting as intermediaries, buying and amassing milk in their localities, shipping it to town for sale on the streets. What in Kenya are called hawkers. It's a bit of a legal gray space, but this is, again, where most people get milk. Opening businesses as milk bar operators. The main take home here is that there's a lot of opportunity for women to benefit from dairy intensification and commercial activity, but not necessarily in the formal sector, which is again construed as a masculine space. Now, I mentioned at the beginning that this research was done in support of policymaker engagement to facilitate planning, and the Inclusive Low Emission Development Project has really taken over the amassing the data generated, the basic research generated through greening livestock, and bringing it into deliberative spaces with both local and national stakeholders. We've been running a series of workshops. The local assessment workshops, which validated the basic research and elaborated our interpretation of it. We developed on the, you see on the right here, this historical pathway of eras of change in the dairy sector since the 80s, trying to understand the trajectory and the various dynamics of change. And this is all emergent from the discussions in the local workshops. Taking these to national workshops, starting to open the discussion for recognizing that low emission development is being pursued, investments are being made, and saying, okay, how can we pursue this in a way that is acknowledges this diversity and acknowledges the issues around inclusivity associated with rapid and intense intensification. These engagements aren't done yet. We've been assessing deliberative capacity and again, bringing people together to start the conversations. The national planning workshops in Kenya and Tanzania are scheduled for the last quarter of this year, September, October, to say, okay, we have all of this data, we have these insights. I'm glad Lini raised the issue of trade-offs. And we have the mandate to pursue lowering greenhouse gas emission intensities, but what are the social and economic pathways toward that, and what are the implications for that intensification? So that we can weigh the potential trade-offs between achieving greenhouse gas emission targets and the SDGs that are also an important touchstone in how rural development policy moves forward. Now, the practical implications from all of this are that I'd like to emphasize are first that low emission pathways are diverse and contingent. These are not singular systems. It's not a single coherent sector, but there's gender differentiation in terms of access to resources. There's variation in households, motivation, willingness, and capacity to invest in low emission development. The structure of value chains, and this is especially true in Tanzania, which is a much more decentralized dairy sector, or I could say localized dairy sectors. Geography, of course, plays a difference, and we see a significant difference between Kenya and Tanzania in terms of the way the sector is organized and the dynamics of change there. And we feel this is just the beginning. There are other aspects of differentiation and contingency that if we want to be effective in implementing low emission development in the dairy sector, we need to accommodate and address all of these up front. Our process has been working on the assumption that this diversity can be accommodated, but we need to have a space to talk about it. To weigh the trade-offs, to understand the implications of various technical pathways. So we need these deliberative spaces. We need inclusive processes that bring various voices to the table, which otherwise aren't always heard in these policy processes. And we need effective partnerships to create the deliberative spaces to make sure inclusive processes are followed. And effective partnerships is everything from getting various ministries to talk to each other, public-private communication, but also recognizing the role of donor agencies in setting priorities and the mandates to include the socioeconomic considerations of change. And at that, I open the floor.
Thank you, excuse me. Thank you very much, Todd, and all the presenters. We have a number of questions, and thank you to the attendees for the questions. I'm going to start with 3 questions, and I think they'll go in order to Lini, and then to Polly, and then to Todd. So Lini, Javira Afzal asks, what does GHG emission reduction intensity exactly mean? So can you explain what emission and reduction in emission intensity means? Polly, Luis Ramos asks, couldn't the increased yield and revenues invite farmers to have more animals, thus offsetting the GHG emission reduction? So would increased yield and revenues encourage farmers to have more animals, thus offsetting any reductions? And Todd, Innocent Bisangwa asks, what did you identify as the driving forces for dairy to be so much a part of the informal economy? So why is dairy so informal? So Lini, would you like to answer the first question on emission intensities?
Thank you, Juliana, and thank you also for the question. So emission intensity is a way of looking at the greenhouse gas efficiency of food production. So it's a joint indicator, not just of emissions, but also of food production. And it's used really in the context of understanding that food security has to be addressed and that productivity will have to increase. And so rather than look at the absolute increase in emissions in many of these systems, we want to acknowledge that there might be some trade-offs in favor of achieving food security. And so we use this emission intensity number. In mathematical terms, or in, to express it more precisely, it's the emissions per unit of food production. So tons of carbon, for example, or tons of CO2 equivalent over a kilogram of food or other product. Thank you.
Polly, do you want to take the question from Luis Ramos?
Yeah, sure. So we often get this question. So you would have to do the business case analysis to see what the to see if you continue to get increased returns as you expanded the herd size. So yes, that what you outline is a risk, but I think we need to remember that farmers keep livestock for a range of functions, and in these mixed systems, they keep them as part of a diversified strategy. So it's not an automatic that they would just immediately specialize in having larger herds if they got greater productivity and greater revenues, because they're not running these operations just as specialized. But yeah, the ultimate goal is to have fewer, more productive animals, so that you're reducing not only intensities but also keeping overall emissions from the livestock sector stable. Thanks.
Thank you, Todd.
Yes, thanks for this question. I would actually turn the question around and say, what are the drivers for, what would be or are the drivers for producers to enter the formal economy? Because the informal economy is that which has existed since forever. It's self-organized. It's its own thing. The formal commercial sector is a relatively new phenomena in the big picture of things, and their processors are always trying to entice producers to join in, to supply milk, to intensify production, to flow more milk toward it. In a more immediate practical terms, in the informal economy, a producer gets a better price. Because they're direct to consumer, they can sell at a much more substantial price, sometimes better than half again the going rate selling to processors. So the processors are currently paying, last I heard it was 30 shillings per liter. That's 30 cents per liter, when the commercial sale is about 110 shillings per liter, $1.10 per liter. So a farmer can get 30 shillings per liter selling to the co-op or the processor, or they can get 45 or 50 shillings per liter selling directly to a consumer, or somewhere in between that, selling to a hawker, an informal middleman. So the financial incentives are actually better in the informal economy if you can get access to direct sale.
Thanks very much, Todd. We'll take 2 more questions right now, and then we'll do probably a last round. So Elaine Grings asks, Polly mentioned increased emissions associated with growing maize silage, primarily from land use change. Please describe that change. Also, what land use change is associated with growing Napier grass? And the other question that we'll take right now, and I'm not sure if this is for Polly or Todd or Lini. So what opportunities exist for scaling out improved fodder growing in East Africa? And he, Agre Ntikamanye asks, could these be opportunities in law, policy, economic, or environmental regulation? So opportunities for scaling out improved fodder growing in East Africa. Polly, why don't we start with Elaine Green's question about maize silage and Napier grass.
Yeah, so this is results from the paper by Patrick Brandt et al. That Lini referred to and I referred to, and so they make assumptions about the increased acreage that would be needed in order to provide the dairy herd in Kenya with sufficient maize silage to achieve the greenhouse gas emissions intensity reductions. And so what they found in that paper is that you would need quite a significant conversion in arable cropland in order to grow that additional maize for fodder silage, and that land use conversion would negatively offset the gains in emissions reductions intensities. In terms of fodder production, and of course, as with all scenarios, the assumptions depend, the outcomes depend on the assumptions that you make. But fodder production, especially on these mixed crop livestock systems, tends to be sort of on the margins of farms or in very small areas. And so their assumptions did not find that such a large amount of land would have to be converted to grow that additional fodder production. So that's my answer to that question. Do you want me to take a stab at the scaling out one and then let maybe Todd add on?
Sounds great. Yeah.
Okay. Yeah. So the challenge really for scaling out improved fodder production is that at the moment, even in Kenya, which has one of the most commercialized dairy sector in East Africa, the several things are lacking. So the first is experience with producing and selling seed that is certified. Farmers' willingness to specialize in fodder production in the way that would be needed to actually make turn it into an enterprise. Related to that is also lack of knowledge about what it takes to produce fodder commercially, and lack of experience with fodder as a value chain. So that's slowly starting to change, and that's why, for example, in the dairy NAMA that Lini mentioned, one of the investment priorities is to stimulate more commercial fodder production, and a number of the interventions that are mentioned there are improved access to extension information, support for developing a better seed supply system. So thanks for the opportunity.
I don't feel like I have a great deal to add to that. I think that captured all of the main points. Maybe we have time for one more question.
Yeah, so I think what we're going to do is take 3 quick questions, and then give about 2 minutes for an open-ended question at the end, if that's okay. So the 3 quick questions. Elias Abraham asks, at what scale was the policy research, was the research made? Do we have findings at small, medium, and large scales of production? So I think Polly or Todd, either of you could take that one. Gwyn Foster asks, what record keeping and traceability in the milk supply chain is going on? Assam Muhammad asks, in the economic study, it discusses milk. Has the byproduct of manure been factored into these scenarios? So those are the 3 quick questions. And the first question actually that was asked is the kind of larger question, and maybe any of you can take a stab at that, and we can discuss, and that is, what can be done to achieve market support for system change to reduce emissions? And I think that's kind of the ringer or the goal of this webinar. So let's take the short questions first. So Polly, Elias Abraham's question about scale of research, small, medium, or large scale of production?
So, right, so we're the vast majority of dairy production in East Africa is with smallholder farmers. So I hope I'm answering your question correctly. And on the manure, no, manure does not, we did not give manure an economic value. There are no markets for manure currently in these systems, although obviously they have a value to farmers in terms of their soil fertility benefits.
Thanks, Polly. How about, so Polly or Todd, attention to record keeping and traceability in the current system?
I don't know that we have looked into that. But certainly there are mechanisms in place in terms of quality assessment at the processor's level anyway.
Sure, and we see like as things move to the more formal market, that will become more important. So Asam Mohammed, oh, you already answered the question. Thank you, Polly, about manure being discussed. So I'd just like to open it up to all of our panelists, this question about your opinions about what can be done to achieve market support for system change to reduce emissions. We'll just take 2 minutes and then we'll thank everyone and close.
I don't know who's supposed to start.
Go ahead, Polly, thanks. I should have said something. Yeah, please, Polly.
Yeah, I mean, so market support, I think Todd and I have tried to take pains to say that there's not just one type of market. At the moment, the formal investment plans. So the main one that's being considered in Kenya at the moment is the dairy NAMA, and they made a deliberate decision to work through the commercial sector, in part because they thought that they argue that you need to work with the large scale processors in order to get the numbers of farmers that will make a return on investment possible, and then also they really want to crowd in private sector investment, and so that's why they're working with the commercial sector, and I think that logic is sound. I hope that the presentation we made has said that there is potential to increase both productivity, revenues, and reduce emissions intensities through some of these low emissions interventions. And there is a huge space and potential for well-designed public and private investment to help get the commercial dairy on that path. And I will let Todd speak to the informal markets.
Yeah, thanks. I think this is a very important topic, and I would start by saying we need to be mindful not to pretend the informal markets aren't a part of it, or aren't a big part of it. Certainly within Kenya, there's indeed a strong discourse about abolishing the informal market because of various reasons, but the fact is that this is where most of the nutrition flows. This is where most of the money flows. I think we would do well to be creative in trying to figure out ways to accommodate and integrate what we now call the informal market system into these interventions, because people do make a lot of money there. There is incentive to in some circumstances to invest in intensification, and I think it would investment in the informal market will likely render outcomes that are more accessible and beneficial to more people, because the pursuit of low emission development needs to be done, even according to the NDCs, needs to be done in conjunction with pursuit of other sustainable development goals. So we need to examine the tensions there and look for our opportunities to achieve environmental targets, but also achieve socioeconomic targets associated with the SDGs, and at the very least acknowledge the trade-offs that might come prioritizing one or over the other.
Thanks so much, Todd and Polly. Well described. So I'd like to thank, we are out of time, so I'd like to thank the panelists and the attendees of this webinar on feasibility and investment potential for low emissions livestock in East Africa. Thank you too to USAID's Office of Global Climate Change for hosting and promoting this series. As you can see, the next webinar in the series will be in the latter half of August. It will be on climate variability, drought and fire, hotspots of current and future fire risk in the tropics, and will feature Lou Verchot from CIAT and Rosa Romancuesta from C4. You can find more information about the series on Climate Links. All right, thank you and goodbye.
Thank you, everyone. Bye-bye.